Hello, this is Keith Gregory. This is my coin toss project. So on the right I have my code, and on the left I have the shell open. So I outline my pseudocode right here. It's not very detailed, but works for me. Okay, so initially I start off with the fair coin toss, and you see I just define it as toss. I import the random module, that comes up later, and then I set up all my placeholders. So M is the sets of tosses, so 5,000. N is the number of tosses per set, and that's 5. L was a list accumulator that I don't really use anymore, but I'll explain later. Head, H is the heads accumulator. T is the tails accumulator. Okay, so first I set up a for loop to loop the number of sets 5,000 times, as you can see with the M. Then I go into setting up the number of tosses with the next for loop within the first for loop. So I loop it 5,000 times for this set of 5, which is N right here. And to randomize the toss, I set the toss to equal random period randant, which allows you to enter a high and low value, and it will randomly select between the high and the low, including the values in between if there are any. And so with that, I use an if statement to determine whether or not it's head or tails, and so I choose 0 to equal heads, and as you can see, I had the print heads, and I had the append heads here, and that has to do with the open list, but when I was running it, it would take too long to print it all out, and it was just a little annoying, so I took that out. Instead, I just left the accumulator in there, which is H equals H plus 1. And so else, when the toss equals 1, do the same thing and accumulate it down here for tails. And so I print the number of heads, number of tails, and then I calculate the probability of getting heads with H%, which is H divided by N times M, so 5 times 5,000 times 100 to get a percent. Same thing with the tails. T% equals T divided by N times N, M, times 100 to get the percentage. And then I print out the probability of heads, and I print out the probability of tails. And so I found it easier to do a completely new function to determine the frequency of N heads and 5 minus N tails. So basically all the code's the same as the first one. The only thing that is really different, the only couple things that are really different, is that I add all these placeholders in there, and you can see that I go through. NA will be the accumulator for 0 heads and 5 tails, and B will be the accumulator for 1 head and 4 tails, and C and D and E and F, they all just, as you can see over here, there's all the accumulators for the different combinations of heads and tails for each flip. So all this stuff's the same. Again, I don't really use this list anymore. Then the next difference is under the initial for loop, which is the number of sets. I have h equals 0 and t equals 0 just to reset the accumulator each time, so I can read the data, which is whether or not how many heads and how many tails in that 5 set, which whatever it correlates to, which one of these it correlates to. So that makes it easier on me, and I just reset it each time, and then I accumulate it, which you can see down here with these if statements. If it was really simple, just if I had h equal 5, I would know that tails would equal 0, and so I would just add it to nf, that is, and so 1 would go to nf, and then it would go to the next one, and if head equals 2, then I would know it was 3 tails, and then nc would have 1 added. And just for the sake of checking, I printed out what NA, NB, NC, ND, NE, and NF equaled, and then I calculated the percentage with NAP, NBP, and so on right here, and I had to change this instead of N times M, just M, because I'm only calculating each set. And then I calculate the percentage again, which I didn't really need to in this case since it was already done, but I did it anyways. And then I printed out all the probabilities of each combination of heads and tails. Okay, next I did the bias toss. Again, I didn't really change much. The whole code's the same. All the placeholders and the accumulators are the same. The only thing that is different is when you come down to the second for loop, you get the toss. I had to change the percentage, and it was really easy. I just did 55 out of 100 values, and so I changed it to 0 to 99, which gives me 100 values to choose from. And if the toss is less than or equal to 54, then I would just accumulate it to H, to heads, and so that would give me 55 out of 100 values are considered heads, so that's a 55% chance. And going through all of this, it's all the same with the percentage calculating and printing out the probability. Okay, and then I did the n heads to 5 minus n tails for the bias toss, and that's all the same with all the accumulators, the same, and with the random.randint change that I made into the bias toss is there too, and that's the only thing different. Okay, and I will run these, starting off with def toss, the toss function. Okay, so I'm going to run the toss function, Okay, you can see down here it prints out the heads, number of heads, and number of tails. And then it prints out the probability and then of heads and the probability of tails. And so it's pretty close to 50-50. If you keep doing it, which I'll do it again, it's again pretty close. So generally it's almost exactly 50-50. Okay. So the next one, I'll do n toss, which is to calculate the frequency of n heads and 5 minus n tails. And so this prints out, as you can see, this prints out the number of each combination right here. So 139, 775, and so on. And then it prints out the probability here. And it explains it out thoroughly. And next I'll do the bias toss. And you can see it's pretty close to 55. So it works out. I'll do it again. Again, very similar. Okay, and next, last but not least, the n bias toss function. So this prints out the probability of all of them, and that's all it does. But that's for the bias toss with each combination. And that is my project.